Hey ladies and gentlemen, my name is Austin Farrar. I'm here at the Challenge program at Georgia Tech, and today we're going to do something a little bit interesting that I've done in my previous videos. We're going to be finding the volume of a torus. That's going to be pretty fun here. But first, I'll make a quick analogy to you guys. So a torus is basically a donut. Okay? That's all it is. Looks like this, top-down view, looks like a donut. Now, I want you to see here is that a donut is really, imagine if you cut a donut, right? If you cut a part of the donut off, and you bent it like this, you get something that looks kind of like this. Now granted, the inside is shorter than the outside, so it would be kind of curved and this wouldn't be possible, but theoretically, it's kind of like this. Okay, so now onto the problem finding the volume of a torus. So first I want to introduce you guys the equation for a circle. So we have x minus x1 squared plus y minus y1 squared equals r squared. And from that, since in this case, we're going to be at the origin, we're going to have x squared plus y squared equals r squared. Okay? Alright, moving on. Now, this is a very brief explanation. You guys can find plenty of stuff on Khan Academy and other things of this nature for more details. But this is just a general idea for the area of a torus to give you a good idea, intuition of what's going on here. Okay, so we have volume in this sense is equal to negative r to r 4 pi r square root of r squared minus y squared. Now, I know what you're thinking. Austin, why are the indices like this and where did all that stuff come from? So what I want you to imagine is back to this picture here. We're trying to find the area from negative r to r. So again, we're trying to find this section here. So that's negative r to r. And we're doing 4 pi r square root of r squared minus y squared. The part that comes in this equation, again, just solving for x here, to plug into this. And then this whole part is right there as well. Okay? And so then we can change it. I changed my indices here in the second portion. Again, I'm going from 0 to r here. And the reason that I'm multiplying that by 2, basically what I'm doing is I'm finding the area of the top half of the donut, and then multiplying that by 2 to represent the bottom half as well. Okay? So once I do that, I'm going to put this equation, I end up taking this out. Eventually I didn't show that step here, but I end up taking this whole thing out and having volume equals 8 pi r, 0 to r, square root of this. Now, if you put this into Wolfram alpha, you'll end up getting 1/4 pi r squared. That's where this comes from. And again, all I'm doing here is I'm replacing this portion over here, putting that into here. And once you multiply that out and do some simplification, you'll get the volume of a torus right here, which is volume equals pi r squared times 2 pi r. That's all the time we have tonight. Thank you guys for watching. Have a great night. And again, feel free to look me up on YouTube and look up Khan Academy as well for some more in-depth explanations. Have a great night.